Okay, we're on our way to section 2.2 now. This section is very short. The technique is very simple. Um, so let's get right down into it. Um, so in 2.2, we're looking at functions called separable. So separable differential equations. And we will define that to mean a DE is separable if it can be written as dy dx. Notice that's just defining your variable for your independent and your dependent variables. That's going to be equal to a product f of y times g of x. Okay, so this is saying that you can factor the differential equation into an expression that depends only on y times an expression only in terms of x or t. You can have a t there too instead of x. So I did want to mention this note here because the textbook uses a slightly different definition, but they mean the same thing. They say a differential equation is going to be separable if it can be written as m of x plus n of y dy over dx equals 0. I don't think that's as useful, but you can see here, right, that dy over dx can immediately be expressed as minus m of x divided by n of y. Or you could write it as minus 1 over n of y times m of x, which you could write as your f of y times your g of x. Okay, so the two definitions are equivalent. So let's see how we would solve this. How to solve a separable differential equation. Solving a separable DE. Well, you want to separate the variables, and you're going to do that by treating this, the dy over dx, in Leibniz form, meaning you're going to treat that as a fraction. And so we're going to rewrite this expression. I'll go ahead and write it again down here as 1 over f of y dy equals g of x dx. Okay, so now you'll notice, right, that this depends only on y, and the right hand side depends only on x. Depends only on x. Oops. Depends only on y. Good. And now it's all set up. We integrate both sides. So then we integrate 1 over f of y dy, and we integrate the other side. And that's it. Now I should say this solution implicitly defines, this is an implicit solution. Implicit meaning that y is not explicitly solved for. Okay. We're going to, many of these we're going to go ahead and solve for y. Sometimes we will say you can leave your answer in implicit form so that you don't have to go through the extra algebra. Because the algebra can be, well, if you haven't done a lot of algebra recently, it can be a little funky, but let's go ahead and try a couple of examples just to see what we're talking about here. So let's go right to the homework, section 2.2, number 14. We'll start off with that one. 2.2, number 14. So here's our differential equation. Y prime equals xy cubed times 1 plus x squared to the minus 1/2 with y of 0 equals 1. All right, so notice that we can write this as a function of x times a function of y, and so we're going to go ahead and separate our variables. maybe I'll just go ahead and separate. So dy, what's going to go on the other side? I'm going to divide both sides by 1 over y cubed, or I should say divide by y cubed. And this side will have x over the square root of 1 plus x squared. And so now when we integrate both sides, that shouldn't be too bad, right? Are you thinking that that looks like a trig substitution? We're not going to do trig substitutions. I know you're disappointed. Well, yeah, okay, we won't do it. But so how we're going to integrate that right-hand side, we'll let u be equal to 1 plus x squared, right? So then du is 2x dx, or 1/2 du equals x dx, right? Remember those? Okay, so then when you integrate this side, that's the other side is going to be a little bit easier. That's the integral of y to the minus 3, right? So that's going to be y to the minus 2 power. So let's go ahead and write that down. Y to the minus 2 power, I'm going to need to multiply by something to get a 1. That would be minus 1/2 is equal to, using my UDU, I'm going to let you go ahead and work that. Well, I'll go ahead and write down the that's going to be the integral of let's see, 1/2 u to the 1/2 power du. Okay, so then your answer is going to be u, let's see, u to the minus 1/2 power. And so your answer is going to be u to the 1/2 power, and that covers the 1/2. So that's going to be equal to, I'll just go ahead and write it down, the square root 1 plus x squared plus c. And be sure and put the c down here. Good. So you know, typically I would, since this is y to the minus 2 power, I don't want to get confused there. So we could just say something like, let's go ahead and take the reciprocal of both sides. So we'd have minus 2y squared is equal to 1 over maybe c plus the square root of 1 plus x squared. Okay, so again, I just took the reciprocal of both sides. Okay, I'm working on solving this for my y. Let's go ahead and get rid of the negative 2 there. So I'm going to go ahead and say negative 2 times negative 2. And so really, you could just write that as 1 over maybe a c2 minus 2 times the square root of 1 plus x squared. That might be a little bit easier to work with. And now we have y of 0 equals 1. So I want 1 to be equal to 1 over c2 minus 2 times the square root of 1, which is 1. And so c2 minus 2 equals 1. c2 equals 3. Good. And so algebraically then we see that we'll go ahead and write y squared is equal to 1 over 3 minus 2 square root 1 plus x squared. Good. So there is our solution so far. But of course I need to solve for y, so how am I going to solve that for y? Well, when I take the square root, I'm going to be taking both positive and negative roots. So do I want the positive root or the minus root for y? And if you guessed already, right, because y of 0 is equal to positive 1, we're just going to be taking the positive root. And so my y of x is equal to 1 over the square root 3 minus 2 square root of 1 plus x squared. Good. So we finished part 1 of that, or part A of that exercise. Part B of that exercise is y defined for all x? Well, you can see we're going to run into a trouble, right? Because we need the denominator cannot be 0, right? And so let's go ahead and solve for where the denominator is 0. Let's see, square root of 1 plus x squared, looks like it's going to be 3/2. 1 plus x squared will be 9/4. That's a 2. X squared is equal to, it's 9 minus 4 is 5. x is equal to plus or minus the square root of 5 over 2. Okay, notice that that breaks the number line into 3 pieces. Okay, which of these intervals, we have 3 intervals, this is interval A, this is interval B, oh, we have more than 3, this is interval C, that's interval D. Which one of those intervals should we choose? Well, we know that y of 0 equals 1, and so we're not splitting at 0. That's a silly thing to do. That's why there was 4. Let me rewrite that. That's not really a split. There we go. Okay, so which one of those should we pick? And I already gave it away because we're picking the interval that contains 0. So therefore, x is inside this interval, and that's it. Good. So, before we go, I know I'm running short of time, but let's go ahead and take a look at the direction field for this, just for fun. That's actually part C, and you can see here, right? This is the direction field from the online plotter, and where we are is we're starting at this point right here. And so you can see that the graph, the solution for y, does not exist along this curve for all x, right? And so this curve is telling us, or this direction field is telling us that we've got the right thing. Very good. Okay, so go ahead and keep that online plotter next to you while you're trying these out, and try plotting the direction fields for those so you can take a look, see what the direction, see what the solution curves look like. It's kind of fun to play around with them a little bit. Oh, by the way, you see that there's a special solution here. Is that going to be a solution? Y equals 0? Maybe not. Well, we can investigate that later. We're out of time. Okay, I'll see you in the next video.